glass, but it's very transparent. You can barely see it. And so that's transparent.
Is that what's on that there?
That's what's on here, right? So if you put dust on that to simulate exploration activity, like a rover kicking up dust on the moon and covering a solar panel or a camera lens with dust, and really get it dirty, then I have a device here that applies. And you know, of course, something like this is not going to be what will fly. We have to develop a much more compact power system. This is what's powering that.
How far are you from a system that can fly?
We are going to test these panels on the space station, outside the space station, in a couple of years. We have a project to do that. It would be a test.
5 minutes, Carlos.
5 minutes, okay. It would be a test, but watch. If you guys can watch that. Yeah, you can take a picture or a video if you want. Ready?
Holy cow.
Wow.
Right. And if you keep it running and you throw dust at it, it'll deflect it.
It's a deflector shield.
And you can dump a lot of dust.
That is a legitimate noise.
Watch you see this is good.
Anyway, so
I'm having Star Trek flashbacks.
so this
The
is
thing is, though, it's
shield.
running at several thousand volts. The current is in the microamps, it's 7 milliwatts of power. It's a
So
very, very small power requirement.
right, small power. So yeah, so that is the technology, and we are applying it to like fabrics for spacesuits, to protect spacesuits from dust, remove dust from spacesuits. Thermal radiators, like if you have spacecraft with a metallic surface, it's going to get hot in the sun, so you have to paint it white. But if it gets dust, then the dust is not as reflective, so it'll get hot, so you need to remove the dust. So we sandwich this circuit, this panel, under, attach it to the metallic surface and paint it over, so sandwich in between the paint on the surface. You can also put it on films that are reflective, that are wrapped around cables and structures that are difficult to paint, like robotic arms, rovers, and so on. And so if you lay a grid, which I have here, and I don't know where it went, with the same reflectivity here, but it's transparent, but the grid is on that, and you put that film on top of it, it's equally reflective, but when you activate it, you remove the dust, and so it'll become reflective again if it's covered with dust. So we're applying, we're turn it off. So we're working on the different applications of that technology. Again, as I said, we're flying it in actually 2015 is when we're flying on the space station, on the outside of the space station. We'll expose it for a year to the space environment and activate it once a day to make sure that it will survive the rigors of the space environment, all the particles, the charged particles, the cosmic rays, the solar radiation, and all of that. So once we do that, then we're sure that we can deploy it on a lunar mission, on a future Mars mission, an asteroid mission, where we can across on systems.
What if I were to touch that while it was on?
Well, if you touch the film, the actual thing, nothing will happen because it's covered with an insulator, so you will not.
So it's safe?
It's safe. It's all safe, and so for an actual, you deploy it. You'll hide the wires. The wires will be under the structure, so you won't see anything.
That's
So,
really cool.
is it creating like a magnetic field that moves out, or
It's
is it
an
just electric field? Okay.
It's an electric field that travels.
Static.
Electrodynamic wave.
Yeah. Okay.
So it's like static?
It's sort of static. We call it dynamic, really, because it's actually traveling. It's a static field that moves, so it's no longer static. So it's an electric field that moves, like a wave.
Unstatic field.
I call it an electrodynamic field. It's an electric field that moves like a wave across the surface. Yeah. Any other How did I get started on NASA? I was a professor, a college professor in Virginia. And NASA has this summer program for faculty, for professors. So and my wife was also a professor, so both of us came a few times as summer faculty to work with researchers here at the Kennedy. And on one of those years, just exactly. Yeah, there was a need for scientists to start some projects, and so they hired us, both of us. Yeah. Yeah. All right.
Thank you so much.
You're
It's
very
really
welcome.
cool to see what you guys are gonna do, and I hope that when you see what we put up on the space station, we can all remember you guys and
Yeah, you know.
see, hey, we met those people.
Right.